Now I want to share with you what are the properties of the vectors if there are two vectors A and B. Then the first property is vector A plus vector B will be equal to vector B plus vector A, that is commutative rule. Now the second, if there are three vectors, vector A, vector B and vector C, then the vectors addition is true for the associative property, that is vector A plus vector B, then vector C is equals to vector A plus vector B plus vector C. Third is the section formula for the vectors. If we have one vector A and vector B, there are two vectors, what is the position vector of that point which separates the joining of two vectors in the ratio of m:n, then vector C is given by m into vector B plus n into vector A upon m plus n if this point C is internally. This is for internally, and if point is externally, then we say it is mb minus na upon m minus n. So we should remember, as and when two vectors are there, then the addition in the order doesn't make any effect. A plus B is equals to B plus A. Commutative property, if there are three, then A plus B plus C is equals to A plus B plus C. This is the section formula. This formula, the third result is named as the section formula. The first one is internally and second is the externally. So in the internally, numerator and denominator both are positive, and in the externally we take the negative sign between these two. So these properties we need to remember, and as and when you want to multiply any vector with the scalar, then a simple and ordinary multiplication takes place. Now I want to share with you few more facts. What are these facts about the vector? That is, if centroid of a triangle is required, is vertices having the position vectors vector A on vertex A, vector B on vertex B and vector C on vertex C. These are the position vectors of the locations of the triangle ABC. If you want to calculate its centroid, then the centroid's position vector G will be given by vector A plus vector B plus vector C upon 3. So ultimately, centroid of triangle, if the vertices are ABC is given by vector A plus vector B plus vector C upon 3. Then components of a vector in three-dimensional system. What are the components of vector if you talk about? If like a room, you have any corner, then there is a length, another is the breadth, and next is the height. These three dimensions are perpendicular to each other. One of them, suppose length, you may assume as x-axis. This is the corner of the room. This line length is x-axis, breadth is taken y-axis and height is taken as z-axis. Then the vectors along length or along x-axis having the components in the form of I as unit vector. Along y we take j and along z we take what? K. So ultimately, if we have three mutually perpendicular lines, then one of them is x-axis, other y-axis and other, the last is the z-axis. So any unit vector along x-axis is given by OA, that is I cap. OA. On the x-axis, we have y and z 0. So, if OA is the length of unit vector, then coordinates of the A on x-axis are 1, 0, 0. Then, if OB is the length of unit vector along y-axis, then the coordinates of the point B will be given by 0, 1, 0, because on y-axis, what is 0? X is 0 and Z is 0. Now, if we talk about the z-axis, for the z-axis, we have 0, 0, 1. Reason being, on z-axis, x is 0, y is 0. OC is the length of unit vector towards z-axis. So, you can say the vector OA is I cap, unit vector OB j cap, and OC vector along z-axis is k cap. Now, the position vector, suppose you have in the space 2 points. One of the point A, coordinates of the point are x1, y1, z1. Another point is B, whose coordinates are x2, y2, z2. Then the position vector of AB is given by x2 minus x1 times of I cap plus y2 minus y1 times of j cap plus z2 minus z1 times of k cap. So, you can say the position vector of AB means position vector of B minus position vector of A, and you need to take care as and when you are moving toward x-axis, it is I cap, y-axis it is j cap, and z-axis it is k cap, the unit vector. Now, the unit vector of AB, suppose AB is any vector, then its unit vector is given by vector AB divided by its magnitude, and saying magnitude means the length of vector. So, if any vector is divided by its magnitude, then we get the unit vector in the direction of the same vector.